My dear children, good morning to you all. I hope everyone is fine, safe and sound at home, isn't it? So I welcome back you again to my physics lecture, video lecture, if I have to be precise. So you all know that we are doing this unit or called this chapter number 2, work, energy and power. We have completed unit A, that is work, energy, power and their measurement. In unit B, we did different forms of energy in the last video, and now today we are going to do unit C, conservation of energy. Conservation of energy, and this would be the last lecture on this chapter. Conservation of energy is our today's topic. Are you getting my point? All right, so let's begin. Okay, before I begin, let me be clear that if you have any doubts, you can ask me anytime. You can text me in the class group or text me personally. I'm always there to help you. All right, so you must let me know if there is any confusion, if there is any queries, any doubts. Okay, if you want to make it clear, let me know. I will be making it clear. Okay, solving your issues. Understood? Okay, so let's begin. Today we are going to do conservation of energy. Energy लाई चाहिँ conserve गर्नु, साँच्नु, राख्नु. All right, so to conserve energy. Now you know, before we study this, we have to learn a principle on which conservation of energy depends. So conservation of energy means you see that energy is such thing that you cannot create it. You cannot create energy, nor you can destroy energy. Are you getting my point? But you can convert or change from its one form to another. For example, the LPG that you use at home to cook your food, LPG is the what energy? It is in the form of chemical energy. But when you burn that, it burns and gives you heat energy. So here the chemical energy which is stored in the LPG is now converted into heat energy. Are you getting my point? So you are not destroying LPG. Actually, you are converting LPG from chemical energy into heat energy. Similarly, in your electric bulb, you are converting electrical energy into light energy and a small portion to heat energy, because you know when the light glows it gets heated up too, isn't it? So in every use of energy, you will see that actually energy in one form is being converted in another form when you are putting it into use. Are you getting my point? So here we are trying to see, in this particular unit we will see that energy is always conserved, means energy is always constant. It only changes from one form to another. Energy चाहिँ एउटा सिस्टममा चाहिँ it is always constant. Fixed amount of energy remains in a given system, but the energy changes from one form to another. This is what we are trying to prove here. Okay, so theoretically we are trying to prove that, okay, whenever a body falls freely, एकदम free भएर चाहिँ fall गर्दैछ, त्यति बेला चाहिँ at each and every point the amount of energy stored in it will remain constant. Did you get me? So if I have to say in another words, if I consider that this is my ground. What is this? This is my ground. I have a stone at this position A. So this is my position A. Are you getting my point? So I am holding the stone at this height, and let this height be H. Ground देखि कतिको माथिसम्म छ? H height को माथिसम्म छ. So when I drop this stone is going to drop and reach the ground here at point. Suppose say this is my C. Are you getting my point? So when this stone from A to C, when it's traveling from A to C, at each and every point the energy is stored in it, or energy consist the energy that is present in this stone will be same, will be constant, or will remain constant. That is what we're trying to see here. Are you getting my point? So at point A, what is happening? I'm holding the stone, so its initial velocity u will be 0, isn't it? So when initial velocity is 0, you know the formula of kinetic energy. Kinetic energy is half mv square. So here now velocity is 0. So when you multiply anything with 0, the result is 0. So here at position A, kinetic energy is 0. Are you getting my point? But in the last video lectures, I've told you that potential energy is given by the formula mgh. So now you know that this stone has certain mass. Let the mass be m. Now it is being pulled by the earth. So when it falls, it will fall with the acceleration. Now that acceleration is produced due to gravitation. So I will have mgh. So here at position A, my potential energy will be mgh. Are you getting my point? Did you understand here? So the total mechanical energy. Now what is mechanical energy? Mechanical energy is nothing but the sum of kinetic energy and potential energy. So at position A, kinetic energy was 0, potential energy was mgh. So when I add them up, the total energy stored in the stone at position, okay, at position A, okay, at position A is how much? mgh. mgh energy चाहिँ केमा रहेछ? स्टोनमा रहेछ कहाँनिर? Position A मा. Is it understood? Now let it fall down. Let it fall down. So it is now falling down. So now it falls down, and suppose it reaches to this position. Are you getting my point? So at this position, let that position be M. Is that, B. Is that okay? So at this, what happens? At position B, okay, its velocity will now, it will have some velocity. Its initial velocity was 0. Now it will have some velocity. Let that velocity be V. Is that okay? Let that velocity be V. And the distance it has traveled from A to the point B be x. So it has traveled a distance of x from A to B. Is that okay? Is it understood? So now at B, we are trying to see at position B, okay, initial velocity was 0. Now the final velocity is V. Okay, so what will be or the value of this final velocity V? So V square equals to u square plus 2as. This is the equation of motion that I have taught you. So from here, if I replace this u with 0, because initial velocity was 0, I'll have 0, 0, 2 into acceleration is due to gravity, so I'll write g, into the distance covered from A to B is x, so I will have v square as 2gx. 2gx. Is it understood? Did you understand here? Okay, so if my velocity square is 2gx, so what will be my kinetic energy here then? My kinetic energy is given by the formula mv square, half mv square. So half mass into v square I got here as 2gx. So here 2 and 2 from the denominator and numerator gets cancelled. So I will have the kinetic energy as mgx. So here, so when I go back to my this initial position here, at point B, my kinetic energy is how much? mgx. mgx. Is that understood? So now, what is the height? What is the height? Initially it was at a height h. Now it has covered a distance of x. So here, this remaining height चाहिँ कति छ? h minus x. So what is my remaining height? h minus x. Isn't it? Okay. So now let me go here again. So at position Okay, B, okay, what is the potential energy is given by mg. Now what is the height? Height is h minus x. So when I remove the bracket, I'll get mgh minus mgx. Okay, so here you see that at position B, kinetic energy is mgx and potential energy is mgh minus mgx. Did you get it? Did you understand here? Clear? So again, let me again explain to you all. Okay, so at position B, this is the ground, this is my stone. At position B, what is the height? Height the originally h थियो, अब त्यसले already x cover गरे, so the remaining height is h minus x, isn't it? Now it was at a मा थियो, अहिले गएर कहाँबाट छ b मा पुग्छ, कति डिस्टेन्स ट्राभल गरेको छ x. So from there I got kinetic energy as mgx. Now here I got potential energy u as mgh minus mgx पाएको छु. So total mechanical energy here, total mechanical energy will be k plus u, that is mgx plus mgh, okay, minus mgx. So plus mgx minus mgx cancels and leaves me behind mgh. So here if I see the figure here again, at position A also the total mechanical energy was mgh. At position B also the total energy is mgh. So A मा पनि mgh नै थियो, B मा पनि mgh नै भयो. Is it okay? Is it understood? All right. Now let me go to point C. Above the stone from A, after reaching to B, it has now reached to position C. कहाँ पुग्यो यो? ग्राउन्डमा पुग्यो. ग्राउन्डमा पुग्दाखेरि h कति हुन्छ? 0. अब कुनै हाइट नै छैन. There is no height. Yes, but A देखिनको C सम्म आउँदा what is the displacement? Displacement S is given by h. Are you getting my point? So h height is in here, the distance covered is h. Are you getting my point? So from the equation v square equals to u square plus 2as, v square चाहिँ मैले कति पाउँछु? Initial velocity is 0 plus 2 into g into the distance covered from A towards 2c is h. So I get v square is 2gh and I get kinetic energy as half mv square, that is half into mv square. So यहाँ मैले कति पाएको छु? 2gh, 2 and 2 gets cancelled, so I'm left with mgh. So at position C, kinetic energy is mgh. But what do you think? What will be the potential energy here? Potential energy त कुन चाहिँ फर्मुलाले दिन्छ? mgh ले दिन्छ. तर यहाँ ग्राउन्डमा आइसकेको छ यो स्टोन, सो हाइटै छैन, सो हाइट कति भयो? 0. So at position, okay, at position, let me go to the initial figure here. Okay, let me also change the color of my pen. So at position C, okay, my potential energy is 0 because it has no height. My kinetic energy is mgh. So the total potential mechanical energy at point C is u plus k, that is 0 plus mgh, that will give me mgh. So here you see that A मा हुँदा पनि mgh नै थियो, B मा हुँदा पनि energy is mgh, at C also the energy is mgh. But the difference that you see here is that at position A, potential energy was mgh, at position C, kinetic energy is mgh. So here you see that energy has been changed from one form to another, that is potential energy into what? Kinetic energy. At position A ma, see, let me make a clear figure. At position A, kinetic energy was 0, potential energy was mgh. Okay, at position B, kinetic energy was mgx, potential energy was mgh minus mgx, and at position C, okay, potential energy is 0, kinetic energy is mgh. So here you see that potential energy has changed into kinetic energy. So this is what or how we can demonstrate that the energy has been conserved and the energy is just converting from one form to another. Alright, so I hope you have understood this. If you have any queries, you ask me in the class group or in me or to me personally. Okay, so today's assignment is to go through your topic number 2.1, 2.17. You go through it by yourself. If you have any doubts, you can ask me. Alright, so that's all for today. Thank you.